So we're going to take a look at the topic called antiderivatives. It's a very simple process, a simple topic to learn, hopefully. Basically, it's the opposite process of differentiation. So far, we've been concentrating on given a function, how do you find its derivative, right? So today, we're going to do the opposite. If I give you a function, how do you find this antiderivative? So if I was to write it like this, say you have g of x. From there, you can find its derivative, right? Today, we're going to go backwards. If I give you g prime, can you give me the original function? And we're going to come up with a few simple rules for that. And this may look like a silly exercise. Why would anybody want to do the antiderivative, right? We've been doing derivatives because it has important applications, right? Well, interestingly enough, antiderivatives have a lot more applications than derivatives. As a matter of fact, the entire course Calc 2, you're going to be working on applications of antiderivatives. And we're going to see some applications of antiderivatives in this class as well after test number 2. Right now, we're just going to learn the simple rules for finding antiderivatives. Just know that there's going to be tons and tons of applications of this. So in a sense, we're going backwards. In a sense, think of the given function being as the derivative of something. You want to get to the bottom of it. Okay, so for example, if the derivative of something is 0, what would be the actual function? So give me a function whose derivative is 0, in other words. A constant, any number would do it, right? So I could put just a c here. And how do you check it? Basically, c prime derivative of a constant is 0. That's how you can check it, that this is correct. Any constant. OK, how about a constant of 5? Give me a function whose derivative is 5. Good guess. I heard 5x, but I even heard a better guess from someone probably who's seen this before. You can actually write 5x plus c, right? Because c has a 0 derivative, right? This is more general, and you're going to see every time you take an antiderivative, you're going to end up with a plus c, basically, okay? And how do you check this? Take the derivative of 5x plus c, and it should give you what you started with, which was 5. So we're good. OK, if you've seen this before, and I'm going to ask you to withhold your answers, let's give the other students a chance, because these are simple if you've seen them. If not, it will take a few moments of thinking, so I don't want to rub them from that thinking process. So if the function given is x, think of this. This is the derivative of something. What is the antiderivative? In other words, give me a function whose derivative is equal to x. You may not get it right away, but give me the idea, like what kind of a power am I going to need to use? You're going to need like x to what? Like for example, if I put an x squared, what is the derivative? 2x. I'm close. There's an x I want to get, but the 2 I don't want. So how will I get rid of that 2? Multiplied by 1/2. Now let's check it again. Okay, what is the derivative of 1/2 x squared? The derivative of 1/2 x squared is 1/2 times bring the 2 down, right? And derivative of c is 0, so do we get x? We did, right? Again, please withhold your answers if you've seen it before, also for the next problem, and also the following one. X squared, I want to know which function, when differentiated, will give you x squared. Which function, when differentiated, gives you x squared? You don't have to get it right away, but give me the x to which power should I begin with? X to the third, but if I just leave it like that, it would be 3x squared, right? How about putting a 1/3 in front? And always you're going to have plus c because derivative of c is 0. We can check it. Derivative of that is 1/3 times 3x squared. The 3's cancel, and we have x squared. So now the general rule. If you have x to the n, what do you think would be the derivative? I'm sorry, the antiderivative. Look at the example of x squared. X squared became x cubed over 3, correct? x to the 1 became x to the second over 2. Now I'm asking you, in general, x to the n will become, I heard several versions and they're all right. One person said 1 over n plus 1 times x to the n plus 1. Or I also heard, I believe, x to the n plus 1 divided by n plus 1. That's also fine. So either way you look at it, it's the same thing. X to the n plus 1 divided by n plus 1, or 1 over n plus 1 times x to the n plus 1. That's the same thing. And let's check it. What would be the derivative of that quantity? Actually, remember, only x is the variable here. N is the number, okay? So bring the power down, right? If you bring the power down, n plus 1 comes down. And subtract 1 from the power. What would you have if you subtract 1 from the power? N plus 1 minus 1 is n, right? So what did I do? I brought the power down and then subtract 1 from the power. I differentiated it. I applied the rule of differentiation to that quantity, and what do we get? X to the n, which is really what we started with. So this is a rule I want you to remember. X to the n, the antiderivative will be x to the n plus 1 over n plus 1. This is the complete opposite of differentiation. Instead of subtracting 1 from the power, you're adding 1. Instead of multiplying by the previous power, you're dividing. So it's a complete opposite process. For instance, 7x to the 5. Let's apply this new rule now, okay? Let's apply this new rule. Just like in the derivative section, the constant, you can keep it as a constant. Just worry about x to the 5. What would the derivative of x to the 5 be now? Antiderivative, I should say. X to the power of 6 divided by 6 plus c. 7x to the 6 over 6. That's your antiderivative. And I'm not going to check from now on because you get the idea. How about the next one? Antiderivative of root x. Root x is the same as x to the 1/2, right? What would be the antiderivative of that? Add 1 to the power, which would give you 3/2. Technically, you're supposed to divide by 3/2, right? You add 1 to the power and divide by that new power. But in this case, you can simplify it. How else could you write this for me? If you divide by a fraction on the bottom, you can rewrite it as 2/3 on the top, x to the 3/2 plus c. Sin x. Give me a function whose derivative is sin x. Somebody said cosine x, but if I just write cosine x there, its derivative is sin x, negative sin x, right? But if I put negative cosine x, that'll work. So I want to remind you, what was the derivative of the sine function? Cosine x. But the antiderivative of the sine function is negative cosine x. Okay? Now let's do the second one, cosine function. Give me a function whose derivative is cosine. Sine, this one was easy. You don't have to modify it in any way. So let me remind you once again, the derivative of cosine was negative sine, right? But the antiderivative of cosine is positive sine. You see this, the plus or minus has changed in antiderivative process. In differentiation, you had the opposite signs, plus or minus, basically. And how about sine of 3x? First, remember this one. Antiderivative of sine is negative cosine. So this is going to be negative cosine of 3x. But the chain rule, when you differentiate it, would multiply by the 3. So you want to get rid of it now. What would you do? In antidifferentiation, you're going to do 1/3. Let's check this one. So in differentiation, you multiply with the 3, right? In antidifferentiation, you divide by that 3. But let's check this one. If you differentiate this, what would you get? The constant remains as it is. What is the derivative of cosine 3x? negative sine 3x times, chain rule says multiply by 3. Now the 3's cancel, the negatives cancel, and you end up with sine 3x. Okay, I'm going to ask you to finish the next few things in your groups. I want you to cosine 2x. Check when you go to your groups. Also, when you go to your groups, I'm going to ask you to do this one. I'm giving you f prime. I want you to find the antiderivative of that function. Okay, let's take a look at the solution to this problem. So suppose that you are given the derivative of a function. The question is, what is the antiderivative? So we're going to go one step at a time. But first, I'm going to rewrite the given function. So 3x to the 5 minus 7x cubed minus 4. And the last term I can write as x to the negative second power. Applying the antiderivative rule, which is x to the n plus 1 over n plus 1. The first one becomes 3x to the 6 over 6 minus 7x to the 4 over 4 minus the antiderivative of a constant is a constant times x. Because again, if you think backwards, the derivative of negative 4x would have been negative 4. And the last one, again, apply the same rule. Add 1 to the power. Negative 2 plus 1 is negative 1. And divide by the new power plus c always. Now I'm going to simplify a little bit. First term is x to the 6 over 2 minus 7x to the 4 over 4 minus 4x. And the last one I can write as negative 1 over x plus c. Okay, let's take a look at another example. Okay, this is a good one. And this is at least an application of antiderivatives that we can look at right away. And remember, in the future, there's going to be many, many more applications. For this question, we are given s double prime. In other words, the acceleration of an object is negative 32 feet per second squared. Suppose we also know that initial height at sub 0 is the initial height is s sub 0, and suppose that initial velocity is v sub 0. Suppose we know those. Suppose those are constants. The question is, what is s of t? Find s of t from this information. Find the distance function if all you know is the gravitational force upon that object. In this case, the gravitational force is negative 32. In other words, the acceleration is negative 32 feet per second squared. Now let's remember what we know from earlier. From early on in chapter 1, if we have s of t, its derivative was s prime, which is velocity, and its second derivative was s double prime, which is acceleration. So for this question, we're going to go backwards. Since we know s double prime, first let's go from s double prime to s prime. Now we need to anti-differentiate, right? So to get s prime, I will anti-differentiate with respect to the variable t. So the negative 32 is going to become negative 32t plus a constant. Now, since I know that s of 0, the initial height is supposedly s sub 0, and I also know that v of 0 is v sub 0. Right now, I'm doing s prime, and s prime is the same as velocity. So this is telling me plug in 0 for t and set it equal to v sub 0. So plug in 0 for t. Get 0 plus c, and set that equal to v sub 0. So that means c is equal to v sub 0. Now I can update my equation then. My S prime with this extra information can be written as negative 32t plus c, but c is b sub 0. So now I've gone one level back up from S double prime to S prime. I still need to go one more step, right? From S prime to S, I'm going to need to anti-differentiate one more time. So now S of t equals the antiderivative of negative 32t. That's negative 16t squared over 2. The antiderivative of v sub 0, remember that's just a constant, that's initial velocity, a number, such as 100 feet per second, whatever it may be, but its antiderivative will be a constant times t, right? Plus, as always, another constant, if you like, let's call that b. And since I know that at 0, when time is 0, initial distance is s sub 0, let's go ahead and plug in 0 for time. And we get 0 squared 0 plus anything times t being 0 is 0 plus b. That must be equal to s sub 0. So from here we get that b is equal to s sub 0. And with that I can modify my equation for the last time, that s of t based on this is equal to, excuse me, I had a mistake in the previous step. Let me clean it up first. So negative 32t, its antiderivative is negative 32t squared over 2, which is negative 16t squared. So I certainly don't need another 2 there, right? Negative 32t squared over 2 already gave me the negative 16t squared. So that was a little mistake. So I fixed that now. So s of t with the addition of this new constant is going to become negative 16 t squared plus v0t plus s sub 0. And this is a very important equation of motion that you might study in physics. And interestingly enough, all we had to know was the acceleration of the object. And once we know acceleration, we can actually determine an equation that represents the path of this object if we know antiderivatives. By taking antiderivative once, we got the velocity function. Antiderivative again, we got the distance function. And so if you know the initial velocity of an object, initial height of an object, then you know the distance from the ground of that object at any given moment t, as determined by this equation s of t. All right, and I want to show you some examples where you can actually determine that constant. So for example, here I give you f prime of x, but I give you extra information that f of negative 1 is 0. And I'm asking you to find f of x. So obviously, to go back from the derivative to the original function, first we need to anti-differentiate. And then let's use the given information. X is negative 1. So f of negative 1 will be equal to 0. So substitute 0 for negative 1 and set the whole thing equal to 0. But before I do that, let me go ahead and simplify this previous line. Okay, and now I can try to determine the c by using the given extra information. So f of negative 1 is, negative 1 to the third is negative. Negative 1 squared is positive. That doesn't change negative 2 in front. Plus 5 times negative 1 is negative 5. Plus c must be equal to 0 based on what's given. So here we have negative 10 plus c is 0. So c is equal to 10. Once we know what c is, we can go back and replace it in the f of x equation. So now f of x is, actually this one is a better one to work with, 3x cubed minus 2x squared plus 5x plus 10. So if they give you something extra, then you can try to determine the constant as well. All right, one more example. All right, one moment, please. Here we go. We have another function. This time we know the second derivative of a function as negative 2x minus 5. Then we have two extra bits of information given to us. The first derivative at 1 is 4. Function value at negative 1 is 2. We are asked to find the original function. And because they give us two extra bits of information, we're going to be able to determine all the constants. Now let's begin with f prime. If you know f double prime, to get f prime, you antidifferentiate once, correct? So let's do that. So take the antiderivative of negative 2x minus 5. At this point, I'm going to use the given information. Since f prime of 1 is 4, I will plug in 1 everywhere I see an x. And this is equal to 4. So I'm getting that c is equal to 4 plus 6 or 10. With that, I know f prime without any constants involved. Basically, that f prime is negative x squared minus 5x plus 10. Now, to get f of x, I need to antidifferentiate one more time. So f of x equals, take the antiderivative of that f prime. So we get negative x cubed over 3 minus 5x squared over 2 plus 10x. Of course, there's always a constant, such as, I'm going to call it again a or b or a different one than c. It doesn't have to be the same constant. Let's say b. And what we're given is that f of negative 1 is equal to 2. So substitute negative 1 everywhere you see an x. So negative 1 to the third is negative, but the initial negative will make that a plus 1/3 minus 5 halves, since negative 1 squared is plus 1, minus 10 plus b is equal to 2. So that means that b is equal to 2 minus 1/3 plus 5 halves plus 10. At this point, you could either use a calculator or get common denominators. In this case, it is 6. And then we can simplify it. So it looks like I'm getting 85 over 6 for my constant. And with that, I can rewrite the function as, so f of x is equal to negative x cubed over 3 minus 5x squared over 2 plus 10x, and now the b plus 85 over 6. And that is our f of x function. And that will be our final answer. So f of x equals to that function. Again, antiderivatives are going to be used a lot in the calculus sequence. This is a good place to get lots and lots of practice of them through your homework in the textbook or your group activities.